Welcome back, guys. So in our previous video we have talked about the variance and the formula which we have derived for the variance. Okay, this is for the variance and this is for the standard deviation which has been mentioned here. So today let us have a scenario in which we have three coin tosses. Okay, three tosses of a coin of and here we have a fair coin in such a way that this is a sequential experiment because a coin has been tossed three times. Okay, and in our first video of this series we have seen that the probability of heads or the number of heads we have to find out, and the probability or the number of heads, okay, or let me write it here, the number of heads in each toss is our random variable x. Okay, so in each toss we can have different number of heads, so the probability of that we have 0 heads is 1 by 8. Okay, the probability that we have the number of heads equal to 1, that is 3 by 8. The probability that the number of heads is 2 is 3 by 8. Okay, and similarly the probability that the number of heads are 3, that is again 1 by 8. Okay, so we have found it out and this was the overall scenario. Okay, for 0 we have 1 by 8, for 1 I have 3 by 8, for 2 I have 3 by 8, and for 3 I have 1 by 8. Okay, we have also found out in our previous videos that the expected value of the number of heads here is what? That is 1.5. Okay, what today we have to find out? We have to find out the variance of this random variable. Okay, so we have here the variance, and the formula for the variance is the expected value of x square, okay, minus mu square, or this is also called mu or expected value of x. Okay, do we have this value 1.5? Yes, we have. So there is nothing to find out about it, but we have to find out the value of x square. Okay, so let me call it formula A, and in order to find this value, what do we have to do? With the formula for it will be what? This will be the x square and the probability of x. Okay, so here applying it, what I will get for the first value, that is 0, we have to find the square of it and multiply it with the probability it has. Similarly, for the second value, that is 1, we have to take the square of it and multiply it with the value of the probability it has, and that is 3 by 8. Similarly, for the third one, we have 2 square multiplied by what? 3 by 8, which is the probability it has, which is given here. And for the last one, we have 3 square multiplied by 1 by 8. Okay, so now let me calculate it. It will be 0 because now this is value 0. Similarly, here we will get 3 by 8. Okay, this will be 2 to 4, 4, 3, 12. Okay, that is 12 by 8, and here we will have 3, 3, 9. Okay, 9, 1, 9, so 9 by 8. Okay, so we will have here 9 by 8. So from it, what I will get? I will get 12 plus 9 plus 3, that is 24, and this will be 8, and that would be what? 3. Okay, so this is the value which is 3, and this is what? This is basically the value or the expected value x square. Okay, so this was B, this was A. Okay, let me take this value which is calculated, or that is the value of ex square, take it and put it here. Okay, in part A, and what I will get, let me move down. So what I will get here, in order to put it down here, we will get, sorry, let me use the white color here. So variance of it will be what? As in for mathematical equation of A, we have here ex square, so that is 3, and we have to subtract from it e of x, that is 1.5. so from it we will get what? That would be variance of it will be 3 minus 1.5 is 1.5. so that is what? That is delta square, and that is 1.5. so that is the answer of our question. In order to find out the standard deviation out of it, what do we have to do? We have to take the square root of this sigma, and that would be 1.5, and that is what? That is the answer for the standard deviation. Okay, so that's it for today, in which we have seen a numerical example which comprises of different values or different probabilities for the different number of hats